All right, ready for another one? I love fractions, don't you? Here we go. Class activity 2E says fractions of non-contiguous wholes. So I had to look this word up. Um, you've probably heard of the 48 contiguous states. That means they share a common boundary. So in this case, we've got a whole that doesn't have a common boundary. That's what that means. So you can read through the definition here, but the problem is that Peter has a garden. The diagram below is a map of Peter's garden, which consists of two plots. And so I think that's the key point here, is that his garden is this area here. He's got two kind of sections to his garden. So that's the whole garden. He doesn't have two gardens. He has one garden with two plots. The two plots have been divided into 5 pieces of equal area. This shaded part shows where the carrots have been planted. Okay, so we planted carrots here. What fraction of the area of Peter's garden is planted with carrots? What fraction of the area of Peter's garden is planted with carrots? You really do need to stop and think deeply about this yourself first. So please do pause the video and really think through this on your own before you look at the student's work. Um, the student's work that we'll look at here shortly has some correct work, some kind of correct work, and some incorrect work. So I really encourage you to think on it on your own. Go ahead and pause the video. Excellent. I hope that you've had some time to think about this. Whether you have the right answer or the wrong answer, you have an opportunity here to kind of think more deeply about it. I'm actually going to jump to the last one on this section. I think it makes more sense to look at Matt's idea first. Actually, let me go back. I want to point something out. In these pictures, these two plots might look about the same area, but they don't have to be. The problem didn't say that. And so if you can imagine, let's just make this really extreme. Okay, remember that these could be different size plots, and if that was the case, that might change some of the answers. So let's look at Matt's. Matt says a fifth of the first plot is shaded. That's true, right? Even if it's larger. And a fifth of the second plot is shaded. That's true. Even if it's smaller, it's a fifth of the second plot. Because there are 2 parts shaded, each of which is 1/5. This means 2/5 of Peter's garden are planted with carrots. What do you think about Matt's reasoning? I probably shouldn't have put the answer there and let you think of it on your own. I'm sorry. The answer is no. It's not okay. The reason is the plots could be different sizes. That's not really the issue. But if they are different sizes, a fifth of plot A and a fifth of plot B is not 2/5 of the garden. In fact, in this case, we've got 3 different wholes. We have plot A as a whole, plot B as a whole, and so you're getting a fifth and a fifth. And then he's adding them and saying that's 2/5 of the garden, but that's not necessarily true. And it's really the same logic, even if the plots are the same size. Now we only have 2 different wholes. We have the plots versus the garden. Hopefully that makes sense. Let's take a look at this. This isn't 2/5 of the garden. The garden is all 10 pieces, right? So it's not just 2/5 of the garden. And then it says, what if the 2 garden plots were the same size and each plot had an area of 1 acre? Could Matt's reasoning be used to make a correct statement? Explain. And this one's actually true. If they're both an acre, then the one plot with the carrots is a fifth of an acre, the other is a fifth of an acre, and together that would be 2/5 of an acre. And what we've really done is gotten away from the garden and we've looked at a new whole, which is an acre, which happens to be the same as a plot. So in that case, a fifth plus a fifth equals 2/5 of an acre does work out. Now, let's go back to the front page and look at part 2. Mariah here. She said there are 2 parts out of a total of 10 parts. So 2/10 of the garden is planted with carrots. What do you think of that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And 2 out of the 10. That seems decent, right? The only issue is these are a lot bigger than these. And so if the two plots had equal areas, then the garden would have been divided into 10 equal parts. That's the key. And then her reasoning works. Since we don't know the plots are equal, we can't use her reasoning because the shaded areas might be larger and smaller than 1/10 of the garden. In this picture, this would be less than 1/10. This would be more than 1/10. Now, if you've thought about this and you've gotten an answer of 1/5 of the garden is shaded, you're actually right. So Mariah's answer is correct. Her thinking is not. And that is if you look at part 3. Isa drew this picture as she was thinking about Peter's garden problem. She took a part from this plot and a part from this plot and put them together. And can you imagine if we made this a lot larger? It would make these pieces a lot larger, but these pieces would all still stay the same size. And so the way she's thinking about it, her picture shows 5 equal parts, these L shapes, and the carrots are 1 out of the 5. So even if the one garden is bigger, the 5 pieces would all be the same size. So it would still be 1/5 of the garden is shaded in carrots, or planted in carrots. So back to the original question. What fraction of the area of Peter's garden is planted with carrots? The final answer is 1/5. This is a challenging one. Don't worry too much if you aren't completely getting all of this. It's pretty involved, pretty intricate. But it's good to think through and think about what happens when these gardens or plots are the same size, and to recognize that the garden is the whole. Thanks a lot, guys. Let me know if you have any questions.